Find the volume of the enclosed region of y equal x squared about the y-axis using the shell method. So use your steps to find the volume using cylindrical shells. The first thing you want to do is sketch your graph. And this is y equal x, that's a straight line, and y equal x squared is a parabola. Step 2 is to draw a rectangle or slab, I will call it a rectangle, parallel to the axis of revolution, about the y-axis. So we're going about the y-axis, and I need to draw my rectangle parallel. So I draw it. It's going to be vertical. And step 3 is to figure out if it's going to be an x problem or y problem. And this will be an x problem because we want to sum up all the rectangles in between an x value of 0 and an x value of 1. So this will be dx. Now the formula is volume equal 2 pi integral shell radius times the shell height dx. So volume equals 2 pi. My integral will go between 0 and 1. The shell radius. So you need to determine what is the radius between the axis of revolution to one of my rectangles. So I'm just going to draw here, because that solid is going about the y-axis, and that is just this distance. Look at the red line. That distance is just some x value. That's the shell radius. Now your shell height is the distance from any of these rectangles, the bottom curve up to the top curve. That's the shell height. It's actually the length of the rectangle that you have drawn. And to find that length, you're going to take the top curve, which is y equal x, and the bottom curve is y equal x squared. So that distance of the rectangle will be the top curve. If you take the top curve minus the lower curve, so top curve is x minus the lower curve is x squared, and this is a dx problem. Let me show that one more time. Your top curve is y equal x, and that distance is this, x. You go up y, you go up y, and that's too much. We're trying to find this distance here, so you need to subtract off the lower piece, and that's the x squared. So the length of any of those rectangles is x minus x squared. You'll need to simplify by using the distributive property and then integrate to find your volume.